Good afternoon. Today we have to study the Hall effect using the Hall effect key. Okay, so this is a Hall effect key, this is a magnet, and this is a Hall probe. Okay, if you can see, there is a two wire, one is a red wire and one is a black wire. So red wire is connected to the red terminal and black wire is connected to the black terminal. Where if you can see, this is a probe. In probe, you can say there is a notch. So you have to connect exactly at the notch center. So with the help of the precaution, you can connect this. Okay, and fix this. Now before inserting the probe into the gear, we have to adjust the distance between the two magnetic fields is 1 centimeter with the help of this block. Okay, so keep the distance between the two magnets north south is 1 centimeter. Okay, the length of this block is 1 centimeter. So I am keeping the block as 1 centimeter. Now before inserting this, okay, we have to start the Hall effect kit. Now I will start the Hall effect kit. Okay, before proceeding, if you can see, say experimental, we are already connected relation to the magnet terminal, connect Hall probe to the probe self circuit. We are connected, keep magnet current and probe current control in middle position. We have it is keeping in middle position. So now first we have to probe current against probe current output current. So if you can see, set the magnet current at any desired value. So we have keep it magnet current as 100 milliamperes plus 100 milliamperes. So now I am keeping it at 100 milliamperes. Okay, so keeping the magnetic current as 100 milliamperes. Note down the current. Do not disturb this setting throughout this experiment. So this is 100 remain fixed. Set the probe current plus minus. This is the plus 100 milliampere. Now adjust the zero control so that probe output meter reads to the 0. Okay, so this now probe reads to the 0. So probe current 0 दिखाना चाहिए and probe current I am adjusting at the 40 and keeping it as 40. If you can see, magnet current is roughly 100 and probe current is a plus 40 and probe, now this is a probe 0, so I am adjusting it at the 0. So this is called as a 0 adjustment. So probe voltage is, all voltage is now 0 before inserting the probe into the magnetic field. So probe current 40, magnet current 100 plus 40 and this is 0. So now I am gently inserting the probe in middle of this circuit. Okay, so now I am keeping it in the middle. So it is exactly, if you can see, this is the middle. Okay, so magnet field 100, you can see that, and corresponding Gauss is 540. The value of the Gauss is already you have to given in this sheets. So for 100 milliampere, you can choose the value is 540. So 540 Gauss for 100 milliampere magnet current. The magnetic field is 540. Okay, and probe current is plus 40. So what will be the value of the Hall voltage you shown in the Hall voltage? You have to write down here. Both are the plus. So minus 0.585 you can write here. So this is the reading for plus 40. Now I am keeping it, this is a minus 40. So अभी ये minus 40 कर रहा हूँ मैं. So if you can see, this is a minus 40. So now you will get the answer is plus 0.85. So magnet current is plus, but probe current is minus. So whatever will the Hall voltage shown on the readings, you have to note down it here. Okay, third time, now this is positive, this is negative. Now I am coming, this is also negative. So I am keep the magnet current in minus 100. So now I am keeping it as minus 100. So this is a minus 100. So minus minus. So minus magnetic field minus 40. Okay. So whatever will the value minus 0.89. So you have to write down minus 0.89. Okay. Now this is minus plus probe current is 40 plus 40. So I am adjusting the side probe current is a plus 40. And this is a plus 40. So answer is plus 0.8. So we will get the minus 0.87 plus 0.87 minus 87 minus 40. So now finally we will get the average, just average of this 4. But you don't bother about the signs. You have to take only magnitude of all these 4 and make the average of these 4. Okay. So this is values for keeping the magnetic field 100 and probe current is 40. So now again in next cycle still magnetic current is minus 100, but now probe current I am adjusting at 50 and so on. So now this is the, so I am keeping the probe current at my 50. Okay, so minus magnetic current and plus probe current. So minus and plus. So minus and plus, you will get the all voltage is plus 145. So you have to write down 1 plus 42. Next time, this is minus 50 and keeping it at minus 50. This is the minus 50, minus 100, and both are the minus, and it is a minus 1.46. So you have to write minus 1.46 for 50 current. Next time this is a positive again. I'm keeping it as a positive 100. So this is a positive 100 and this is a minus. So 1.33 your original answer, and finally both are the positive. So plus 100 plus 50. Your answer is minus 1. You have to write down and again average. Still, so in the first table, keeping the magnetic field 100 constant and now varying the probe current from 40 to 120 milliampere, and you have to note down the corresponding pole voltage on the pole voltage and readings, and you have to find out the average of all this. So this is the reading for first set. In next set, magnet current you have to keeping at the 200. Now I am keeping the magnet current at 200, but the same procedure, and probe current as 40. Again for the 4 different values of combinations plus minus plus minus plus and plus minus minus, and we will get the 4 different values of voltages. And similarly for the keeping magnetic field to magnetic current 200 fixed and vary the probe current from 40 to 120. Note down the value of the all voltage and you have to find out the average of these 4 values and corresponding thing. Whereas similarly for the 300, keeping the magnet current at 300 and keeping the magnet current at this is a 300 and probe current from 40 to 120 milliampere. We have to again same get the 4 different values of whole voltage, find the average then. So you will get the, this is a part 1. So and finally then we have to find out the slope, that is a for part 1 using the, you have to draw the 3 different slopes. You will get the 3 different slope graphs for the part 1. So you can say this is a for IS current 140, second this is IS current for IM current for 100, IM current for 200 and IM for 300. We will get the 3 different slopes and substitute the value of slope in this formula and calculate the value of RH. So roughly we will get the RH values around 100, 5.70 centimeter cube. This is for part 1. But in part 2, now we have to keep the magnet field probe current constant, that is a 40. So now in second case I am keeping the 40 is a constant. So this is a 40. So probe current is 40, and now I am varying the magnetic field from 50 to the 450. If you can see, 50, 50 and 40. So again both are the plus. Note down the value of the old voltage, then plus minus, minus plus and plus plus. So you will again get the 4 values and 4 average of the VH. So similarly, keeping the IS constant, vary the magnet current from 50, then 100, then 150, 250, 250, 300, 350, 400 and 450. So this is the part 2 values. Again you will get the different values of the all voltage, and finally you will get the answer. So again you draw the second graph for the part 2. We will only just do the one graph in value in which hope is again this. So and finally again you for part 2 you find out the value of RH, which is again roughly 100, and then mean value of the part 1 and part 2 you will get the value of the RH. Now there is a value formula for N, that is the number of concentration is 1 upon RH square. So you substitute the value of R, you will get the number of concentration, which is 1.8 into 10 raised to 16 centimeter cube. So this is a complete explanation about the Hall effect using Hall effect kit. So now viva for this question is what? So firstly that is what is the Hall effect? Explain the Hall effect which you already studied in SSB papers. Okay, applications of the Hall effect. So what are the different types of concentrations, or either what are the different types of semiconductor? So what is a semiconductor? Okay, p-n junction and n junction semiconductor. So in diodes there is a, we already studied the diode have the holes and concentration. So with the help of this Hall effect we can find out the any concentrations of charge carrier using the semiconductor